Let's also display the dedupe.bam file. So I'll say ls bams/star.dedupe.bam. So these are the final BAM files. So we are going to call FreeBayes and then identify the variants from these samples. These are the final BAM files. These are 3 samples here. All right, so that's what we are going to do next. Now, if you are going to use FreeBayes to call variants from multiple samples, then there are 2 approaches you can use. You can either call variants from the individual samples and later merge the VCFs, or you can supply FreeBayes with all the samples at once, i.e. the BAM files. So in this tutorial, we are going to supply FreeBayes with all the BAM files at once. So before we do that, we need to do some preparation. So I'll first generate an index file. So this index file is the .fai file. So we have to use some tools to do that. So I'll say some tools and I'll say with X, and then I'll supply it with the reference sequence. So I'll say ref/ag19. Yeah, there's the file. So let's execute this command. Perfect. So that has been done. So if I do an ls into the ref directory, I'm going to find that file here. So there's a .fai file. All right. We also need to store the path to the files, the BAM files here. We need to store the path to a text file. So to do that, we need to display and then redirect the output to a file. So we'll use the same command here and then add something else. So I'll say ls bams/star.dedupe.bam, and then I'll direct to an output file. So I'll say bam.list. So now if I do an ls, I'm going to find the bam.list file here, and then I'll say cut bam.list to display the contents. So I have them here. Nice. There is something else we need to do. So let's clear the screen and continue. Let's do an ls. Let's display the bam.list again. Right. Now we are going to create a directory called VCF. So I'll say make the VCF. Nice. Now the preparations are complete, so we can call FreeBayes. So I'll say FreeBayes, and then I'll say -f, and then supply it with a reference sequence. So that will be ref/ag19, etc. So there's a reference sequence. Now we have to indicate the BAM file. So I'll say -l, and then I'll say bam.lists, and then I'll say --vcf, and then I'll say vcf/variants.raw.vcf. Perfect. So this becomes our final command. So let's execute this command. All right. So FreeBayes is working now. It will take some time, so be patient and wait for everything to get done for you. All right. FreeBayes has completed this work. So if I do an ls, I'll find my VCF directory. I can ls into it to see my VCF file. So this VCF file here, I name it raw because normally after variant calling, you need to process the VCF further. So this becomes the raw VCF and then you can process. So with the processing, you can remove low quality variants, so snips and indels. You can also decide to subset, maybe get variants for a particular sample, or you may want to also get variant for a particular chromosome, or you can also filter based on quality and style. So there are a number of things you can do here. So those things, I've covered some of them already, and I'll also cover some of them later on. But for now, you just have to learn how to call variants. So after calling the variants, you can use tools like VCF tools, etc., to process the VCF further. And then you can also use other downstream analysis tools to analyze your data. For example, after variant calling, you can perform variant annotation. You can also look at variant effects. So you can also do your GWAS analysis, etc. There are a lot of things you can do here. So it depends on the questions that you want to answer. But everything starts after you have generated your VCF. So this is why this tutorial comes in handy. So learn this to generate your VCF files, and then you can proceed with your analysis.